Hello everyone. Under dynamic programming approach, we will see now the next point, that is longest common subsequence. The concept of LCS, that is longest common subsequence, is as under. The longest common subsequence type problem have two sequences, that is set of character or strings given. We have to find the longest possible subsequence which is common in both the subsequences or sequences. A subsequence is a sequence that appears in the same relative order but not necessarily contiguous. So we skip some character in the sequence in order to make the common subsequence. Few examples are as follows. The LCS, that is longest common subsequence, for sequence A, B, C, D and ACF is AC of length 2. And these are two more examples where the output is ADH for these subsequences of length 3, and the output for the third one is GTAB for these given subsequences of length 4. This can be more clear when we solve this problem using dynamic programming concept or approach. So this is an example of LCS which we will solve using dynamic programming approach. That is, find the longest common subsequence of two strings, that is ABCBDAB and BDCABA. So these are the given strings of the different characters. Using dynamic programming approach, we will have to solve this. So let us start with the solution. For longest common sequence for these input sequences, that is first one and second one, we will have to start with the approach as below. First of all, we will have to write these subsequences in vertical and horizontal manner in this way. That is, the first one we will write vertically starting from A, B, C, B, D, A, B, and horizontally B, D, C, A, B, A. The next step is associated to each character. Here we will have to start with one more horizontal row and labeled with zeros corresponding to each character. Similar way, for the vertical characters also we will have to add zeros associated to each character, and this 0 is common to both vertical as well as horizontal characters. Now the next, in this space we will have to fill some numbers and the arrows, so that comes under the solution. So here, for making the solution of this problem will go in two different phases. The whole problem we will solve from here in two different phases. First, we will add some numbers here by following some predefined rules or the steps, and associated to each number we will add some arrows. These arrows are upward arrows or vertical arrows toward left side or diagonal arrows toward top left corner side. So that is shown like this. So this is the first phase of solving the problem. After this, it is filling the numbers in the table, that is in this table, and second phase is putting arrows to each number. So whatever numbers we got in this space, to each number we will associate one type of arrow making the direction towards the left side or upward direction or top left corner side. So this is an example of that. So this will be getting after solving whole problem. So this will be the last step that I am directly showing here, but meanwhile in between we will see the steps to get these output. So this is how the numbers we will get in this table, and the second phase is to get the arrows like this. So you can see here many arrows are in upward directions, few of the arrows are in the left side horizontal direction, and few of the arrows are diagonally shown, which are directed towards top left side. So we will have to associate each and every number with one particular arrow like this. To each and every number we associated these arrows. So these are the steps to solve the problem. Why this will be done, that we will see in the further slides. Now we will start with the first phase. So suppose, for example, this is the sequence of numbers given, and suppose we will have to find the number at this junction here shown by the question mark. If suppose I click it once, it is shown with red color. So this red color box, suppose in this case we will have to find this particular number. So we will follow the principle of this particular box, or otherwise this particular box, to fill this number. Whatever is appropriate, whether this upper one or lower one, that will be fixed to find out the value for this particular question mark. Like this, to find out further values, we will have to group the 4 different values and find the 4th value, right? So here in this case, so this X and this X indicates the associated alphabet related to this particular value that we will have to find. So the associated value of this particular value is in this case B and in this case B. So B and B, the alphabets towards the vertical end and the alphabet towards the horizontal end associated to this value which we have to find. If it is same, here it is X, it is X. In that case, what we do, we add 1 to the diagonal, and whatever value we got, we will write to this particular place. So in this case, the associated diagonal value or adjacent diagonal value is 0. So 0 plus 1, that will become 1. So this will become 1. So for this particular scenario, we will use this upper one, the upper diagram here, or upper table. So here we'll see here, these are darkened here. So this B and B is darkened, and simultaneously X and X are darkened, means these are similar. So if suppose I click it, it become 1. So 0 plus 1, that become 1. So this is one example how we will solve it. In another case, for this particular box, we will see one more example here. Say suppose we will have to find this particular value, and suppose in that time we will have the other values like this. So at this time, the associated value to this particular question mark is B here, and associated alphabet here is C. So this C and this B are different. So that is shown here by Y and X. So that can be shown here by this darkened highlighters. So here this C is associated to Y and B is associated to X for this particular value, right? So here what we will do, amongst this B and C, whatever value is big, that value we will take it as a value, actual value here. So out of these two values, 3 and 1. So when this will be the case, when these alphabets are different for this particular value, at that time the associated or adjacent value above this value and the adjacent value beside this value on the left side, out of these two values, whatever value is bigger, that value we will take and consider for this particular place. So in this case, it will become 3. So out of these two values, it will become 3. One more example, if suppose for the same place, if you want to calculate the value, in this case the alphabet here and the alphabet here is different. So in this case, we will have the approach that out of these two values, that is 4 and 2, we will take one which is bigger out of these two. So in this case it is 4. The 4 will be gone here. So we will consider here 4. Now the next thing is the second phase of this problem. That is, after we got filled all the values in this table here, we will have to place the arrows beside each and every number. those arrows are left directed, or otherwise upward directed, otherwise top left side or top left directed, or diagonal, it is in diagonal direction. So now, for example, here this is the arrow that we will give as per this example. Here you can see here x and x. What's the meaning of this? If you wanted to give arrow to this particular darkened box, we will have to check whether the associated alphabet to upward to this and in this line is similar or not. So here for this particular one, the alphabet B and here alphabet B is same. In that case, we can give here the arrow which is directed towards top left. In similar way, we can see that here B is here. So here also we can give the same arrow with the same direction. So whatever number of times we will get the alphabet similar at the upward direction and at the horizontal direction, at all those times for that particular value we will give this type of arrow. Next is when we will have to give the left arrow to the value. So whenever I want to give some left arrow to this particular value or whatever they are here the value, at that time what I have to check here, the value of y and x here, the value of y and x. At that time I will not check the value of this alphabets the alphabets at this vertical line and this horizontal line. So when this particular diagonal direction alphabet arrow is allowed here, only at those places wherever the alphabets are similar. Apart from that, this rule will not be applicable, right? So this rule, wherever the alphabets are same at vertical and horizontal line, at those places only we will use this diagonal direction arrow. At all those places except this, we will use the following two rules. So now here for the next example here, for giving the left directed arrow, here we will have to check two values, that is adjacent to wherever we want to give the arrow, adjacent to that value we will see two values, that is the value at above and value beside this, that is left side. In this example, if suppose we have 0 here, so this 0 is above this one and this one is left side to this 0. At that time we will have to place arrow by this rule. If y is greater than x, that is if this y value is greater than x, at that time we will give the left side arrow. At the same time, if the y value is equal to or the x value is greater than y, means y value is less than x, at that time we will give the upward arrow, right? So that can be shown here with this example. So here wherever I am getting the same value b and b and again b and b, for this particular row we will try to give the arrows. For showing you the example, only this row I am using here now. If suppose I wanted to give the arrows to remaining ones, so here I will not give because already I have given the diagonal directional arrow here. So I will skip this. Again I will consider only these 4 values and here I will be giving some arrow here. So check what value comes here or what type of arrow comes here. So here we will check these 2 values, this 0 and this 1, and this is applicable here. Why? Because this y value is greater than this x value. So we will give this arrow, that is left directed arrow. So this is done. Similarly, we consider this box now. So here these are the 4 values. Now here what arrow we will give here? We will consider this value and this value. So this is as good as this x and this is 0 is as good as this y. So in this case the y value is less than x value, right? That is x is greater than y. At that time for this particular value we will give the upward directed arrow. In the same way for this particular value we will give which arrow? If suppose these are same, so here y equal to x, so here also we will apply which arrow? Upward directed arrow. In the same way for this particular box it is already given as diagonal directed arrow, so skip it. And again for the last value, here this y value is greater than this x, that is y value is greater than the x, so here we can give the left directed arrow like this. So like this, for each and every value we will check for these particular conditions, and as per the condition we will try to give the arrows to the left directed or to the upward directed or to the diagonal directed directions. So this is how we will place the values and as well as the arrows. So now we will try to fill one by one here using the first phase. So what first phase tell you? If these and these are matched, or if x and y are unmatched, and we will try to give the values to each and every places. So we will start from this first one. So here this 0 0 0 here we are considering, I will try to put the value here only. So here we will check this x and x, means this a and b are unequal. So as a and b are unequal, then what we do? We'll write bigger of this. Now in this case 0 and 0, we can directly write 0 here. So this is one. Second, again a and d are unequal, and we will write the bigger of these two values. So bigger is nothing, so we can put here 0. Again for this a and c are the values associated with this particular place where we will have to place the value. So here, as these are different, so here we will have the bigger of these two. Unmatched, this is called unmatched, AC, unmatched. If AA, it is matched, we can say matched. Now again A and A. See now here it is something different. Here to fill the value at this particular place, the alphabets associated at this particular place is A, and here horizontally A. So this is same. So this x and x means these two values are same. So we will add 1 to this value, that is A plus 1. So this will become 1, right? Next, here this A and this B are different. If these are different, we will have this particular rule. So here we will put the bigger of both these, the bigger of BC. The bigger of BC is what? C is bigger. So here it will be 1. So like this we go on putting the values. Again A and A are same. If A and A are same, then in that case this becomes this rule. This rule is applicable there. So A plus 1, that is 0 plus 1. So we will put here also 1. Again we will come down and try to put here something. So to put here something, we will have to make box to these particular 4 values, right? So here again we will start with the same procedure. The B and this B is same. So that is why here we will put this plus 1, that is 0 plus 1. So it becomes 1. Again in the similar way, B and D are unequal. So bigger of this is 1. Again for this, B and C are different. If they are different, we will put here bigger of these two, that is this rule. So as per the rule, we will check whether this rule applicable or this rule applicable for that particular shaded region, and accordingly we will write the values here. So here again B and A, these are different. As these are different, bigger of this one, it is become 1 only. Again for the next, this B and this B are same. So we will add 1 to this diagonal opposite value or adjacent value. So this become 2, and similar way this become 2. As this B and this A are different, the greater of these two values is 2, we write here. So like this we have to write all the values, right? Here see, it becomes 2 again. So here the C and A are different, right? So this bigger of these two, 2. In the same way, C and B are different, bigger of 2. then C and A are different, the figure of 2, it is 2. Again for this box B and B are same, so 0 plus 1, that is 1. For this box B plus B and C are different, so bigger of these 2, it is 2. For this box B and C are different, so bigger of these two values. Again for this B and A are different, so bigger of 2. So like this we are going putting. So here we got 3. How we got 3 here? B and B are same, so 2 plus 1, that is become 3. So here we got 3. So like this, by applying the upper rule or the lower rule here, we are gradually putting each and every value and fill this table in this way. At last, this B and this B are same, 0 plus 1, that is this rule. For this here, this B and D are different, so bigger of these 2. B and this C are different, bigger of 2. B and this A are different, bigger of 2. Then B and this B are same, so 3 plus 1, that is become 4. And the last one is this B and A are different, so bigger of this, that is become 4. So in this case, in this way, we got the values and filled the whole table like this. So now the next phase is what? As I already explained in the previous slides, once we got all the values filled in this table, the next step is to give different types of arrows associated to each and every value. That will be useful to find out the LCS. So these are the rules to give the arrows to these boxes. So here already explained you, wherever we got the similar kind of alphabets associated to any box, there first of all we start drawing the diagonal arrows here. See here, at every place wherever we got the intersected values or alphabets similar, there we have this diagonal directed arrow, B, B, A, A. So like this we will fill all these arrows. Then we start with the first one. So here this is for the upward directed arrow and left directed arrows. Now those are remaining here. So now in this case these two values are same. As these two values are same, we will use what? This upward arrow. Now in this case, don't think of the alphabets at the intersection of this value. Don't think of the alphabet in this case. So now here for this box, these two values are same, upward direction. For these three values, these two values are same, again upward direction. This is already diagonally directed, so nothing can be done here. So in this case, these two, out of these two values, this value is greater, that is y is greater than the left directed arrow. In this case, upward directed arrow. This is already given, skip it. Here these two values, y is greater, so left directed arrow. In this case, y is greater, the left directed arrow, this is true here, y is greater than x, not this one, y is greater than x, so left directed arrow. Here in this case both are same, so y is equal to x, so upward directed arrow. Again in this case already given as this arrow, skip it. In this way, here y is greater than this x, so this arrow. Again here x is greater than y, the upward arrow. So like this I am putting all these arrows by applying these rules. Now once we got to put all this arrow and find out this type of table where it is a combination of numbers as well as arrows, afterwards the final step to get the solution is shown in the next slides. Once we got this, the next step is what? We'll have to start with the last value and go as per the direction given by the arrow. Wherever this arrow follows you or carry you in that direction, we will have to go up to the first value. See here, this is saying me to go up. This is saying me to go in diagonal direction. So I am just going on the diagonal direction. This is saying me to go in upward direction. I am going upward direction. This is saying me to go in diagonal direction. So I am going in the diagonal direction. This is saying me to go in the left side. So I am going in the left side. This is saying me from here where to go in diagonal direction. So I am just going in diagonal direction. This is saying me to go in left side, right? Then this one is saying me to go up, right? In this way I reach up to the first value, the first 0. In this whole path, wherever I got the values at the intersection of the similar alphabet will become the longest common subsequence. That is, in this path I got here B and here B, so this value, then again at this value C, C, again at this place, that is B and B, again at this place, that is A and A. Here these will be shown with the red color arrows. So here on the same path, wherever I got the arrows which will indicate the same alphabets at that intersection, that is here at this intersection we got the same alphabets vertically as well as horizontally. At this particular arrow we got the same alphabets vertically as well as horizontally. At this arrow we got the same alphabet, that is B and B, at this same alphabet at this intersection, and here also. So all these values are become the longest common subsequence for this problem. So that is BB, CC, A, BB and AA. So the longest common subsequence for this problem will be BCBA, that is shown with this solution and answer. Thank you.